Question 1. Stakeholder feedback indicates that a critical business unit is experiencing significant performance degradation on a specific virtual machine hosting a customer-facing application. The business unit manager has requested an immediate adjustment to the virtual machine's resource allocation, specifically increasing its CPU and memory limits, citing the need to restore service levels urgently. However, the IT infrastructure team has not yet fully investigated the root cause of the performance issue, and there are concerns that such an adjustment might negatively impact other virtual machines sharing the same host or potentially introduce unforeseen stability issues. Option A. Initiate a detailed performance analysis of the affected virtual machine and its host environment, gathering specific metrics and logs before proposing any resource adjustments. Option B. Immediately implement the requested CPU and memory limit increases for the virtual machine to address the stakeholder's urgent request. Option C. Escalate the request directly to senior IT management, highlighting the urgency and the potential impact on the business unit without conducting any initial investigation. Option D. Inform the business unit manager that their request cannot be prioritized at this time due to other ongoing critical infrastructure maintenance. Correct answer is A. Initiate a detailed performance analysis of the affected virtual machine and its host environment, gathering specific metrics and logs before proposing any resource adjustments. Explanation. Scenario analysis. This scenario presents a professional challenge stemming from conflicting stakeholder priorities and potential data privacy implications within a virtualized environment. The core conflict lies between the immediate need for performance optimization, driven by a key business unit, and the broader organizational responsibility to maintain data integrity and security, as mandated by general IT governance principles. The pressure to deliver a quick fix without thorough investigation raises concerns about unintended consequences and potential breaches of trust or compliance. Correct approach analysis. The correct approach prioritizes a systematic, data-driven investigation before implementing any changes. This aligns with best practices in IT service management and data governance, which emphasize understanding the root cause of issues before applying solutions. By engaging with the affected business unit to gather detailed performance metrics and then performing a controlled analysis of the virtual environment, the IT team demonstrates due diligence. This methodical approach ensures that any proposed solution is targeted, effective, and minimizes the risk of introducing new problems or compromising data security. It upholds the principle of responsible system management and proactive risk mitigation. Incorrect approaches analysis. Implementing the requested configuration change immediately without investigation fails to acknowledge the potential for unintended consequences. This approach disregards the principle of least privilege and could inadvertently expose sensitive data or degrade performance for other critical services. It represents a failure in due diligence and a potential violation of internal IT policies regarding change management and risk assessment. Escalating the issue to senior management without attempting initial troubleshooting or data gathering is an inefficient use of resources and bypasses established problem-solving protocols. While transparency is important, premature escalation can create unnecessary alarm and may not provide management with the necessary context to make informed decisions. It suggests a lack of confidence in the team's ability to resolve issues independently and can undermine established support structures. Ignoring the stakeholder's request due to perceived low priority is unprofessional and detrimental to stakeholder relationships. Even if the request seems minor, it originates from a business unit and warrants a professional response. Dismissing it outright can lead to dissatisfaction, erosion of trust, and a perception of poor service delivery, regardless of the technical merit of the request. Professional reasoning. Professionals should adopt a structured problem-solving methodology. This involves clearly defining the problem, gathering relevant data, analyzing potential causes, evaluating solutions, implementing the chosen solution with appropriate controls, and verifying the outcome. In situations involving stakeholder requests and system changes, it is crucial to balance immediate needs with long-term stability and security. A risk-based approach, where potential impacts are assessed before action, is paramount. Open communication with stakeholders, managing expectations, and providing clear justifications for decisions are also key components of professional conduct. Question 2. Which approach would be most appropriate when a vendor strongly advocates for the immediate adoption of their new virtualization management solution, claiming it offers significant performance improvements and cost savings, but the IT team has not yet had the opportunity to conduct a thorough, independent evaluation? Option A. Politely decline the vendor's offer, citing a lack of immediate need and a preference for sticking with the current, well-understood virtualization platform. Option B. Initiate a structured proof of concept (POC) to objectively assess the vendor's solution against current infrastructure performance metrics and define business requirements, while simultaneously exploring alternative solutions. Option C. Immediately deploy the vendor's solution across a critical production environment to capitalize on the claimed immediate benefits and demonstrate responsiveness to vendor recommendations. Option D. Agree to a limited pilot deployment in a non-critical test environment, but without establishing clear success criteria or a formal process for evaluating its long-term viability. Correct answer is B. Initiate a structured proof of concept (POC) to objectively assess the vendor's solution against current infrastructure performance metrics and define business requirements, while simultaneously exploring alternative solutions. Explanation: this scenario presents a professional challenge due to the potential conflict between a vendor's aggressive sales tactics and the IT professional's responsibility to make objective, technically sound decisions. The pressure to adopt a new technology, even if not fully vetted or demonstrably superior, can lead to suboptimal infrastructure choices, increased costs, and potential security vulnerabilities. Careful judgment is required to balance business objectives with technical integrity and ethical conduct. The correct approach represents best professional practice because it prioritizes a thorough, objective evaluation of the proposed technology against established technical requirements and business needs. This aligns with professional ethical guidelines that mandate competence, integrity, and objectivity. By conducting a proof of concept and seeking independent validation, the IT professional ensures that the decision is data-driven and serves the organization's best interests, rather than succumbing to external pressure or perceived vendor urgency. This methodical approach minimizes risk and maximizes the likelihood of a successful and beneficial technology adoption. An incorrect approach that involves accepting the vendor's claims without independent verification fails to uphold the principle of objectivity. This could lead to the adoption of a solution that is not fit for purpose, is overly expensive, or introduces unforeseen compatibility issues, thereby failing the duty of care to the organization. Another incorrect approach, that of immediately rejecting the technology without any evaluation, might be driven by bias or a lack of willingness to explore potentially beneficial innovations, thus hindering progress and potentially missing out on valuable advancements. A third incorrect approach, that of agreeing to a pilot program without clearly defined success criteria or a formal exit strategy, risks wasting resources and time on an unsuccessful initiative and could be seen as a failure of due diligence and responsible resource management. Professionals should employ a decision-making framework that begins with clearly defining the problem or opportunity. This is followed by identifying potential solutions, which in this case would include the vendor's proposed technology and other alternatives. Each solution should then be rigorously evaluated against predefined technical, security, and business criteria. This evaluation should include objective testing, such as proof-of-concept exercises, and consideration of total cost of ownership and long-term support. Finally, the decision should be documented, justified, and communicated to relevant stakeholders. Question 3. The review process indicates that a junior administrator, while performing routine maintenance on a VMware vSphere 6.5 environment, observed what appeared to be unauthorized access to sensitive client data within a virtual machine storage. The administrator is unsure of the exact nature of the access, but suspects it may violate data handling policies. What is the most appropriate course of action for the junior administrator? Option A. Discuss the observation with colleagues informally to gauge their opinion before taking any formal action. Option B. Ignore the observation as it is likely a false alarm and could cause unnecessary concern if reported. Option C. Access the virtual machine directly to investigate the suspected unauthorized access and gather more evidence before reporting. Option D. Immediately escalate the observation to the designated compliance officer and document all details of the observation for further investigation. The correct answer is D. Immediately escalate the observation to the designated compliance officer and document all details of the observation for further investigation. Explanation. The review process indicates a potential conflict of interest and a breach of professional ethics related to the handling of sensitive client data within a virtualized environment. This scenario is professionally challenging because it requires balancing the immediate need for operational efficiency with the long-term imperative of maintaining client trust and adhering to data privacy regulations. The core of the challenge lies in ensuring that access to and use of client data within the VMware vSphere 6.5 environment is governed by strict ethical principles and regulatory compliance, even when faced with internal pressures or perceived shortcuts. The correct approach represents best professional practice because it prioritizes data integrity, client confidentiality, and regulatory adherence. By immediately escalating the issue to the designated compliance officer and ensuring all actions are documented, the professional demonstrates a commitment to ethical conduct and a proactive stance in addressing potential violations. This aligns with the principles of professional responsibility, which mandate that individuals act in the best interests of their clients and uphold the integrity of their profession. In the context of data virtualization, this includes safeguarding sensitive information from unauthorized access or misuse, which is paramount for maintaining client trust and avoiding legal repercussions. An incorrect approach that involves directly accessing and reviewing the client's sensitive data without proper authorization or escalation would constitute a serious ethical and regulatory failure. This action bypasses established protocols for data handling and security, potentially leading to unauthorized disclosure or misuse of confidential information. Such a breach could violate data privacy laws and professional codes of conduct, resulting in severe penalties for both the individual and the organization. Furthermore, it erodes client confidence and can lead to reputational damage. Another incorrect approach, such as ignoring the observation or attempting to resolve it independently without involving the appropriate oversight bodies, is also professionally unacceptable. This inaction or unilateral action demonstrates a disregard for established procedures and a failure to recognize the potential gravity of the situation. It can allow a breach of protocol to persist, increasing the risk of data compromise and regulatory noncompliance. Ethical professionals are expected to be vigilant and to report any suspected irregularities through the proper channels, ensuring that issues are addressed comprehensively and in accordance with legal and ethical standards. The professional decision-making process in such situations should involve a clear understanding of the organization's data governance policies, relevant data privacy regulations, such as those pertaining to the jurisdiction of operation, which for this exam is assumed to be a general framework applicable to virtualization environments without specific country mandates unless otherwise stated, and the company's code of conduct. When an ethical dilemma arises, a professional should 1. Recognize the potential issue and its implications. 2. Consult relevant policies and regulations. 3. Escalate the concern to the appropriate authority, e.g., compliance officer, legal department, or supervisor. 4. Document all observations and actions taken. 5. Cooperate fully with any subsequent investigation. This structured approach ensures that decisions are made responsibly, ethically, and in compliance with all applicable standards. Question 4. The analysis reveals that a virtualized data center environment is experiencing suboptimal resource utilization, leading to increased operational costs and potential performance bottlenecks. To address this, a strategy is being considered that involves a comprehensive review of virtual machine configurations, including CPU and memory allocation, and the implementation of automated tiering for storage based on access frequency. This strategy aims to right-size resources, reclaim unused capacity, and ensure that data is stored on the most cost-effective tier without impacting accessibility. Option A. Implement a phased approach to right-sizing virtual machine resources and storage tiering, starting with non-critical workloads and progressively moving to more critical systems, while continuously monitoring performance metrics and cost savings. Option B. Rely on vendor recommendations for automated resource optimization tools without conducting an independent assessment of current resource utilization or performance baselines. Option C. Immediately reallocate all available CPU and memory resources from underutilized virtual machines to those experiencing high demand, and migrate all data to the fastest available storage tier to eliminate potential bottlenecks. Option D. Focus solely on increasing the overall compute and storage capacity of the data center to accommodate future growth, assuming that current inefficiencies will be absorbed by the expanded infrastructure. Correct answer is A. Implement a phased approach to right-sizing virtual machine resources and storage tiering, starting with non-critical workloads and progressively moving to more critical systems, while continuously monitoring performance metrics and cost savings. Explanation. The analysis reveals a common challenge in data center virtualization environments: optimizing resource utilization without compromising performance or incurring unnecessary costs. This scenario is professionally challenging because it requires balancing competing demands, maximizing the efficiency of existing hardware, ensuring application responsiveness, and adhering to budgetary constraints. A misstep can lead to either underutilized, expensive infrastructure or over-provisioned resources that strain the budget, both of which negatively impact the organization. The correct approach represents best professional practice because it prioritizes a data-driven, systematic methodology by first establishing baseline performance metrics and then implementing changes incrementally. It allows for precise measurement of impact. This aligns with principles of responsible IT resource management, which emphasize informed decision-making based on observable data rather than assumptions. This methodical approach minimizes risk and ensures that any optimization efforts are demonstrably beneficial and sustainable. An incorrect approach that focuses solely on aggressive overprovisioning, future-proof, the environment fails to consider cost-effectiveness and resource efficiency. This can lead to significant capital expenditure on hardware that may never be fully utilized, representing a direct violation of sound financial stewardship and potentially violating internal IT governance policies that mandate cost optimization. Another incorrect approach that involves making broad, sweeping changes without baseline measurements or phased implementation introduces a high degree of risk. This can lead to unintended performance degradation, service disruptions, and increased troubleshooting overhead. Such an approach demonstrates a lack of due diligence and a disregard for the stability and reliability expected of a virtualized data center, potentially contravening service-level agreements, SLAs, and operational best practices. A third incorrect approach that relies on anecdotal evidence or the latest vendor marketing without independent validation ignores the specific needs and characteristics of the organization's unique workload. This can result in implementing solutions that are either ill-suited or overly complex, leading to wasted resources and a failure to achieve genuine optimization. This demonstrates a lack of critical thinking and a failure to apply professional judgment based on the specific context. Professionals should employ a decision-making framework that begins with a thorough understanding of current performance and resource utilization. This involves establishing clear, measurable objectives for optimization. Subsequently, potential solutions should be evaluated based on their potential impact, cost, and complexity. Implementation should be phased, with continuous monitoring and validation at each step. This iterative process ensures that optimizations are effective, efficient, and aligned with business goals, fostering a culture of continuous improvement and responsible resource management. Question 5. The risk matrix shows a high probability of delays in virtual machine provisioning due to manual intervention in resource allocation and configuration. To address this, which of the following strategies best balances process optimization with maintaining data integrity and system stability? Option A. Focus solely on optimizing the existing manual provisioning process by training staff on faster techniques, deferring any automation efforts until a future project. Option B. Implement a phased automation approach for virtual machine provisioning, starting with non-critical development environments, followed by rigorous testing and validation before extending to production, with a documented rollback plan. Option C. Introduce a new, unproven third-party provisioning tool without extensive internal testing, relying on vendor claims of efficiency and security. Option D. Automate the entire virtual machine provisioning workflow using a scripting solution, deploying it immediately across all production environments to achieve maximum efficiency gains. The correct answer is D. Automate the entire virtual machine provisioning workflow using a scripting solution, deploying it immediately across all production environments to achieve maximum efficiency gains. Explanation. This scenario presents a professional challenge due to the inherent tension between optimizing process efficiency and maintaining data integrity and security within a virtualized data center environment. The need to streamline operations, as indicated by the risk matrix highlighting potential bottlenecks, must be balanced against the strict requirements for data protection and compliance, which are paramount in any IT infrastructure. The specific jurisdiction for this exam is not explicitly stated, but for the purpose of this question, we will assume a general best practice framework applicable to professional IT operations, emphasizing principles of due diligence and adherence to established IT governance standards. The correct approach involves a systematic, phased implementation of process optimization techniques, prioritizing thorough testing and validation at each stage. This aligns with best professional practice by ensuring that any changes do not negatively impact system stability, performance, or security. It demonstrates a commitment to risk mitigation and proactive problem solving, essential for maintaining a reliable and compliant data center. This approach is ethically sound as it prioritizes the integrity of the data and the continuity of services, thereby protecting the organization's assets and reputation. An incorrect approach would be to implement changes without adequate testing or rollback plans. This represents a significant regulatory and ethical failure. It violates principles of due diligence, potentially leading to data loss, system downtime, or security breaches, all of which could have severe legal and financial repercussions for the organization. Another incorrect approach would be to bypass established change control procedures. This undermines the governance framework, increases the risk of unintended consequences, and demonstrates a lack of professional responsibility. Such actions can lead to non-compliance with internal policies and external regulations, exposing the organization to audit failures and penalties. Professionals should employ a decision-making process that begins with a comprehensive understanding of the current state, identifies specific areas for improvement based on objective data, like the risk matrix, and then develops a detailed plan for change. This plan must include risk assessments, testing protocols, rollback strategies, and clear communication channels. Prioritizing changes based on their potential impact and feasibility, and always adhering to established change management processes, are critical steps in ensuring successful and responsible optimization. Question 6. The evaluation methodology shows that a VMware vSphere 6.5 data center is experiencing performance degradation. To address this, several optimization strategies are being considered. Which strategy best aligns with a professional approach to process optimization in a virtualized environment? Option A. Aggressively over-provision CPU and memory resources for all virtual machines to ensure they have ample capacity, regardless of current utilization levels. Option B. Immediately migrate all virtual machines to a newer, proprietary VMware feature set to leverage its advanced capabilities, assuming it will inherently resolve performance issues. Option C. Bypass formal change control procedures and directly modify critical vSphere configurations in the production environment to implement perceived optimizations. Option D. Implement a phased approach, starting with thorough performance monitoring to identify specific bottlenecks, followed by targeted adjustments to resource allocation and configuration based on observed data, with rigorous testing and validation at each stage. The correct answer is D. Implement a phased approach, starting with thorough performance monitoring to identify specific bottlenecks, followed by targeted adjustments to resource allocation and configuration based on observed data, with rigorous testing and validation at each stage. Explanation. The evaluation methodology shows a critical juncture in optimizing a VMware vSphere 6.5 data center environment. The professional challenge lies in balancing the immediate need for performance improvements with the long-term implications of architectural decisions, particularly concerning resource allocation and potential vendor lock-in, all within the context of established operational best practices and the implicit regulatory framework governing data center operations, which, for this exam, is assumed to be a general IT governance framework emphasizing efficiency, security, and compliance, without specific jurisdictional mandates beyond standard industry expectations. Careful judgment is required to ensure that proposed optimizations do not inadvertently introduce instability, security vulnerabilities, or violate service-level agreements. The correct approach represents best professional practice because it prioritizes a systematic, data-driven, and phased implementation. This aligns with ITIL principles of service transition and continuous service improvement, ensuring that changes are well understood, tested, and their impact is measurable. By focusing on identifying bottlenecks through performance monitoring and then implementing targeted, incremental changes, it minimizes risk and allows for validation at each step. This methodical process is inherently compliant with general IT governance principles that mandate risk management and change control. An incorrect approach that focuses solely on aggressive resource over-provisioning, without a clear understanding of actual demand, fails to adhere to principles of efficient resource utilization and cost management, which are implicit in responsible data center operations. This can lead to unnecessary expenditure and can mask underlying architectural issues rather than resolving them. Another incorrect approach that involves a wholesale migration to proprietary features of a single vendor without a thorough cost-benefit analysis and risk assessment for future interoperability and flexibility violates the principle of maintaining architectural agility. This can lead to vendor lock-in, making future technology transitions more complex and expensive, and potentially contravening procurement guidelines that often require competitive sourcing and avoidance of undue dependency. A further incorrect approach that bypasses formal change control procedures and implements optimizations directly in a production environment is a direct violation of fundamental IT governance and operational security best practices. This significantly increases the risk of unplanned downtime, data corruption, and security breaches, which are unacceptable in any regulated or professionally managed IT environment. The professional decision-making process for similar situations should involve a clear understanding of the current state, defining measurable objectives for optimization, conducting thorough impact assessments, developing a phased implementation plan with rollback strategies, and establishing robust monitoring and validation mechanisms. This structured approach ensures that optimizations are effective, sustainable, and compliant with operational and governance standards. Question 7. During the evaluation of a proposed security hardening initiative for a VMware vSphere 6.5 environment, a stakeholder expresses urgency to deploy all recommended security patches and configurations immediately to mitigate perceived external threats. However, the IT operations team has not yet completed a full impact analysis or established a rollback plan for these changes. Which of the following approaches best balances the need for enhanced security with operational stability and adherence to best practices? Option A. Apply the security patches and configurations only to critical production systems that are directly exposed to external networks, leaving other systems at their current security posture. Option B. Defer the security hardening initiative until a more comprehensive security audit can be completed, even if it means delaying the implementation of known security improvements. Option C. Proceed with the immediate, full-scale deployment of all security patches and configurations across the production environment to address the perceived threats as quickly as possible. Option D. Implement the security patches and configurations in a staged rollout, beginning with non-production environments to validate functionality and performance, followed by a carefully scheduled deployment to production with a documented rollback strategy. The correct answer is D. Implement the security patches and configurations in a staged rollout, beginning with non-production environments to validate functionality and performance, followed by a carefully scheduled deployment to production with a documented rollback strategy. Explanation. This scenario presents a professional challenge due to the inherent conflict between the immediate need for enhanced security and the potential impact on existing operational stability and compliance. The VMware Certified Professional 6.5 Data Center Virtualization Delta exam focuses on the practical application of virtualization technologies within a data center context, implying adherence to best practices and established operational procedures. The correct approach represents best professional practice because it prioritizes a structured, risk-aware, and compliant implementation of security enhancements. This involves thorough planning, testing, and stakeholder communication, ensuring that the proposed changes align with the organization's security policies and operational requirements without introducing unforeseen disruptions. This methodical process is crucial for maintaining the integrity and availability of the virtualized environment, which is a core responsibility of a VCP. An incorrect approach that bypasses proper change management and testing procedures poses significant regulatory and ethical risks. Such an approach could lead to unintended service disruptions, data corruption, or security vulnerabilities, all of which could violate internal policies and potentially external compliance mandates related to data protection and service availability. Failing to document and validate changes also undermines accountability and auditability, which are fundamental to professional IT operations. Another incorrect approach that focuses solely on implementing the latest security features without considering compatibility or performance implications is also professionally unsound. This can result in a degraded user experience, increased operational overhead, or even system instability, negating the intended security benefits. It demonstrates a lack of holistic understanding of the virtualized infrastructure and its interconnected components. The professional reasoning process should involve a clear understanding of the business objectives driving the security enhancement, a comprehensive assessment of the technical implications, adherence to established change control processes, and proactive communication with all affected stakeholders. This systematic approach ensures that technical decisions are aligned with business needs, operational realities, and regulatory expectations, fostering a secure and reliable data center environment. Question 8. Operational review demonstrates that the current VMware vSphere 6.5 environment is nearing its end-of-support life, presenting potential security vulnerabilities and limiting access to critical patches. The IT department is considering options to address this, balancing the need for modernization with budget constraints and the potential for operational disruption. Which of the following approaches best aligns with professional best practices for managing this transition from a stakeholder perspective? Option A. Undertake an immediate comprehensive Big Bang upgrade of the entire vSphere environment to the latest version over a single weekend, without extensive pre-migration testing or a defined rollback plan, to minimize the perceived disruption duration. Option B. Defer any upgrade or migration activities until a critical failure occurs or until mandated by a new regulatory requirement, focusing solely on maintaining the current environment's uptime with minimal expenditure. Option C. Implement a phased migration strategy to a supported vSphere version, starting with non-critical workloads and conducting thorough testing and validation at each stage, while maintaining clear communication channels with all affected business units regarding timelines and potential impacts. Option D. Proceed with upgrading the vSphere environment to a newer version using the most cost-effective solution available, without consulting with key business stakeholders or assessing the impact on their specific application dependencies. The correct answer is C. Implement a phased migration strategy to a supported vSphere version, starting with non-critical workloads and conducting thorough testing and validation at each stage, while maintaining clear communication channels with all affected business units regarding timelines and potential impacts. Explanation. This scenario presents a professional challenge rooted in the inherent tension between maintaining operational stability and the need to adopt new technologies for improved efficiency and security. The challenge is amplified by the fact that the existing infrastructure, while functional, is approaching its end of life, posing potential risks. A key aspect of this challenge is balancing the immediate costs and disruption of an upgrade against the long-term benefits and the mitigation of future risks. The stakeholder perspective is crucial here, as different groups will have varying priorities and risk tolerances. The correct approach represents best professional practice because it prioritizes a structured, risk-aware, and stakeholder-aligned transition. By conducting a thorough assessment of the current environment, identifying critical dependencies, and developing a phased migration plan with robust rollback capabilities, the organization minimizes the risk of service disruption. Engaging with stakeholders to understand their concerns and secure buy-in ensures that the project aligns with business objectives and that potential impacts are managed proactively. This approach demonstrates due diligence and a commitment to responsible IT governance, which are implicitly expected within professional IT practice, even without specific regulatory mandates for this exact scenario. An incorrect approach that focuses solely on immediate cost savings by delaying the upgrade fails to acknowledge the escalating risks associated with end-of-life hardware and software. This can lead to increased vulnerability to security threats, potential compliance issues if support is withdrawn, and ultimately, higher costs due to unexpected failures and emergency fixes. This approach demonstrates a lack of foresight and a disregard for the long-term health and security of the data center, Another incorrect approach that involves an immediate, large-scale, big bang migration without adequate testing or rollback plans is professionally reckless. While it might seem like a quick solution, it carries an unacceptably high risk of catastrophic failure, leading to significant downtime, data loss, and reputational damage. This approach ignores fundamental principles of change management and risk mitigation. A third incorrect approach that proceeds with the upgrade without proper stakeholder consultation or communication creates an environment of distrust and potential resistance. It fails to acknowledge that infrastructure decisions have broader business implications and that buy-in from affected departments is essential for successful adoption, and to ensure that the new environment meets their operational needs. This can lead to unforeseen operational hurdles and a perception of IT as an isolated entity rather than a strategic partner. The professional decision-making process for similar situations should involve a systematic evaluation of the current state, a clear definition of desired future state, a comprehensive risk assessment, and the development of a phased, manageable plan. Crucially, this process must include continuous engagement with all relevant stakeholders to ensure alignment, manage expectations, and facilitate a smooth transition. Prioritizing risk mitigation, operational continuity, and business value should guide all decisions. Question 9. Governance review demonstrates that a critical business unit requires the rapid deployment of several new virtual machines to support an upcoming marketing campaign. The virtualization team has the capacity to deploy these VMs quickly, but doing so would require bypassing the standard change control board (CCB) approval process and skipping the full suite of security vulnerability scans and performance tests to meet the aggressive deadline. The team is also aware that updating the Configuration Management Database (CMDB) and associated documentation for these new VMs would be delayed until after the campaign launch. Which approach best balances the business need for speed with the operational and security requirements of the virtualized data center? Option A. Inform the business unit that the deployment cannot proceed until all standard change control, security, and performance testing procedures are completed, and the CMDB is updated, even if it means missing the campaign deadline. Option B. Proceed with the deployment of the virtual machines, prioritizing the business deadline by bypassing the CCB, deferring full security and performance testing until after the campaign, and updating the CMDB post-launch. Option C. Deploy the virtual machines after obtaining expedited CCB approval for a streamlined testing and documentation process, ensuring critical security checks and essential performance validation are completed before launch, and committing to immediate post-launch CMDB updates. Option D. Deploy the virtual machines without CCB approval or formal testing, but ensure the CMDB is updated immediately to reflect the new infrastructure. The correct answer is B. Proceed with the deployment of the virtual machines, prioritizing the business deadline by bypassing the CCB, deferring full security and performance testing until after the campaign, and updating the CMDB post-launch. Explanation. Scenario analysis. This scenario presents a common challenge in data center virtualization environments where the need for rapid deployment of new services conflicts with established change management and security protocols. The pressure to deliver quickly can lead to shortcuts that bypass critical validation steps, potentially introducing vulnerabilities or operational instability. The challenge lies in balancing agility with robust governance and risk management. Correct approach analysis. The correct approach emphasizes adherence to the established change management process, including thorough testing and documentation. This aligns with best practices for maintaining a stable and secure virtualized environment. From a regulatory and compliance perspective, especially within a framework like VMware's operational guidelines, which implicitly support industry standards for IT service management (ITSM) and security, this approach ensures that changes are auditable, traceable, and have undergone necessary risk assessments. It upholds the principle of least privilege and ensures that new deployments do not inadvertently compromise the integrity or availability of the data center infrastructure. Incorrect approaches analysis. One incorrect approach involves bypassing the Change Control Board (CCB) and proceeding with deployment without formal approval. This is a direct violation of change management policies, which are designed to prevent unauthorized or untested changes from impacting production systems. Ethically, It undermines team accountability and can lead to a breakdown of operational discipline. From a compliance standpoint, it creates an audit gap and could lead to non-compliance with internal policies and potentially external regulations if the change introduces security risks or service disruptions. Another incorrect approach is to deploy the new virtual machines without performing comprehensive security vulnerability scans and performance testing. This directly contravenes the principle of secure system design and deployment. It introduces significant operational risk, as unpatched vulnerabilities can be exploited by malicious actors, and performance bottlenecks can impact existing services. This failure to conduct due diligence is a breach of professional responsibility to ensure the integrity and security of the IT infrastructure. A third incorrect approach is to deploy the virtual machines without updating the Configuration Management Database, CMDB, and associated documentation. This leads to an inaccurate representation of the production environment, making troubleshooting, incident response, and future change planning significantly more difficult and error-prone. It erodes the foundation of effective IT operations and can lead to prolonged downtime and increased operational costs due to misidentification of assets and dependencies. Professional reasoning. Professionals should adopt a risk-based approach to change management. When faced with pressure for rapid deployment, the decision-making process should involve 1. Understanding the business criticality of the new service and the potential impact of delay. 2. Assessing the risks associated with any proposed deviation from standard procedures. 3. Communicating these risks clearly to stakeholders, including management. 4. Seeking explicit approval for any expedited or modified processes, ensuring that critical validation steps are not entirely omitted but potentially streamlined with appropriate compensating controls. The ultimate goal is to deliver business value while maintaining the security, stability, and compliance of the data center environment. Question 10. Regulatory review indicates that a critical data center virtualization upgrade involving a new storage solution is being considered. The primary driver for this upgrade is to improve application performance for a single, high-priority business application. Given the urgency, there is pressure to deploy the solution rapidly with minimal disruption. What approach best balances the immediate need for performance improvement with the imperative to maintain data integrity, security, and overall system stability? Option A. Deploy the new storage solution with only basic functional testing, prioritizing the performance needs of the single critical application over broader system impact. Option B. Select the most cost-effective storage solution available and deploy it quickly, assuming it will meet performance requirements. Option C. Implement the new storage solution directly into the production environment immediately to address the performance bottleneck for the critical application. Option D. Conduct a comprehensive proof of concept (POC) in a lab environment that mirrors production, followed by a staged rollout to production with continuous monitoring and a documented rollback plan. The correct answer is D. Conduct a comprehensive proof of concept (POC) in a lab environment that mirrors production, followed by a staged rollout to production with continuous monitoring and a documented rollback plan. Explanation. Scenario analysis. This scenario presents a professional challenge involving the implementation of a new storage solution within a virtualized data center environment. The challenge lies in balancing the immediate operational needs of the business with the long-term implications of data integrity, performance, and compliance. Stakeholders, including application owners, security teams, and compliance officers, will have varying priorities and concerns. A rushed implementation without proper due diligence could lead to data loss, performance degradation, security vulnerabilities, and regulatory noncompliance, all of which carry significant financial and reputational risks. Careful judgment is required to ensure the chosen solution meets technical requirements while adhering to established best practices and regulatory mandates. Correct approach analysis. The correct approach involves a phased implementation strategy that prioritizes thorough testing and validation. This begins with a comprehensive assessment of existing infrastructure and business requirements, followed by a proof of concept (POC) phase. The POC allows for real-world testing of the new storage solution in a controlled environment, simulating production workloads and identifying potential issues before full deployment. This iterative testing, validation against performance benchmarks, and security hardening are crucial. The final deployment should be staged, with rollback plans in place, and accompanied by comprehensive documentation and training. This approach represents best professional practice because it minimizes risk, ensures data integrity and security, and allows for adjustments based on empirical evidence, thereby aligning with the principle of due diligence expected in IT infrastructure management and data handling. Incorrect approach is analysis. Implementing the new storage solution directly into the production environment without a POC or staged rollout is a significant regulatory and ethical failure. This bypasses critical validation steps, increasing the risk of widespread service disruption, data corruption, or security breaches. Such an approach demonstrates a disregard for risk management principles and could violate data protection regulations that mandate reasonable security measures and data integrity. Deploying the solution with minimal testing, focusing solely on meeting the immediate performance demands of a single critical application, is also professionally unacceptable. This narrow focus neglects the impact on other applications and the overall data center infrastructure. It fails to consider potential performance bottlenecks, resource contention, or security implications for the broader environment, which could lead to broader compliance issues related to service availability and data protection for all users. Choosing a solution based primarily on cost savings without a thorough technical and security evaluation is another regulatory and ethical misstep. While cost is a factor, prioritizing it over functionality, security, and reliability can lead to a solution that is inadequate, insecure, or non-compliant. This can result in hidden costs due to performance issues, security incidents, or the need for costly remediation, ultimately failing to serve the best interests of the organization and its stakeholders. Professional reasoning. Professionals should adopt a risk-based approach to infrastructure changes. This involves identifying potential risks, assessing their likelihood and impact, and implementing controls to mitigate them. A structured methodology, such as a phased implementation with rigorous testing and validation, is essential. Stakeholder engagement throughout the process is critical to ensure all concerns are addressed and to foster buy-in. Documentation and clear communication are paramount for accountability and knowledge transfer. When faced with competing priorities, the decision-making process should always weigh the potential impact on data integrity, security, availability, and regulatory compliance above short-term gains. Question 11. Market research demonstrates a significant increase in demand for faster data access within the data center, prompting a need to expand storage capacity and performance. A VMware administrator is tasked with implementing a solution to meet this demand, considering the addition of new high-performance storage arrays. Before proceeding with the hardware acquisition and integration, what is the absolute first step the administrator must take to ensure compliance with VMware's licensing framework for vSphere 6? 5. Option A. Review the existing VMware vSphere 6. 5 End-User License Agreement (EULA) and any associated support contracts to determine current licensing entitlements regarding storage capacity and features. Option B. Implement the new storage arrays and then proactively contact VMware support to inquire about potential licensing adjustments after the fact. Option C. Upgrade the vCenter server to the latest available version to leverage advanced storage management capabilities that might accommodate the new hardware. Option D. Procure and install the new high-performance storage arrays immediately to address the urgent business need for faster data access. The correct answer is A. Review the existing VMware vSphere 6. 5 End-User License Agreement (EULA) and any associated support contracts to determine current licensing entitlements regarding storage capacity and features. Explanation. Scenario analysis. This scenario presents a professional challenge where a VMware administrator must balance the immediate need for increased storage performance with the long-term implications of licensing and compliance. The pressure to deliver a solution quickly, potentially driven by business demands or perceived urgency, can lead to overlooking critical licensing terms. The core challenge lies in making a decision that is technically sound, cost-effective, and, most importantly, compliant with VMware's end-user license agreements, EULA, and any relevant contractual obligations. Failure to adhere to licensing terms can result in significant financial penalties, legal repercussions, and reputational damage. Correct approach analysis. The correct approach involves a thorough review of the existing VMware vSphere 6. 5 licensing agreement, specifically focusing on the terms related to storage capacity, and any limitations or entitlements associated with the purchased licenses. This proactive step ensures that any proposed solution, such as adding new storage arrays, aligns with the purchased entitlements. If the current licensing does not permit the intended expansion, or if additional licenses are required, the next step is to consult with the VMware licensing team or authorized reseller to understand the available upgrade paths or purchase necessary licenses. This approach represents best professional practice because it prioritizes legal and contractual compliance, which is a fundamental ethical and professional obligation. It mitigates risk by preventing unauthorized use of software, which could lead to audit failures and penalties. Adhering to the EULA is a direct requirement of using VMware products and ensures the integrity of the virtualized environment from a legal standpoint. Incorrect approaches analysis. Implementing the new storage array without verifying licensing compliance is a direct violation of the VMware EULA. This approach is professionally unacceptable because it assumes entitlements that may not exist, leading to software license noncompliance. This could trigger an audit by VMware, resulting in demands for back payment of licenses, significant fines, and potential suspension of support. Ethically, it represents a disregard for contractual obligations. Upgrading the vCenter server to a version that might offer enhanced storage management features without first confirming if the existing vSphere licenses cover such advanced functionalities is also a risky approach. While technically, it might seem like a way to improve management, if the underlying vSphere licenses are tied to specific feature sets or capacity limits that are exceeded by the upgrade or its intended use, it still constitutes a licensing violation. This could lead to similar audit and penalty scenarios as the first incorrect approach. Purchasing additional storage hardware and integrating it without any consideration for the VMware licensing implications is a failure to perform due diligence. The question is not just about hardware capacity, but about the software's ability to manage and utilize that capacity within the bounds of the license agreement. This approach ignores the critical link between hardware and software licensing, creating a high risk of noncompliance. Professional reasoning. Professionals facing such a decision should employ a structured decision-making framework that prioritizes compliance and risk management. This framework typically involves 1. Information gathering. Understand the business requirement, increase storage performance, and the technical constraints. 2. Regulatory/contractual review. Thoroughly examine all relevant licensing agreements, EULA, and support contracts. This is the absolute priority. 3. Impact assessment. Evaluate the technical feasibility and the licensing implications of various solutions. 4. Solution design. Develop a solution that meets technical requirements while remaining fully compliant. 5. Consultation. Engage with legal, procurement, and vendor representatives, VMware in this case, as needed to clarify licensing terms and options. 6. Implementation and verification. Implement the compliant solution and verify its adherence to all terms. 7. Documentation. Maintain clear records of all decisions, reviews, and justifications. Question 12. Consider a scenario where a critical business application is experiencing intermittent performance issues, and a key stakeholder urgently requests a direct modification to a virtual machine's network adapter settings within the VMware vSphere 6.5 environment to resolve the problem. This modification has not been previously tested or documented as part of a standard change management process. As a VMware certified professional, what is the most appropriate course of action to ensure both the immediate operational need and the long-term integrity of the data center virtualization infrastructure? Option A. Immediately implement the requested network adapter setting change on the production virtual machine to address the stakeholder's urgent concern, assuming the stakeholder has the authority to approve such a deviation. Option B. Proceed with the requested network adapter setting change directly on the production virtual machine, but make a note in the virtual machine's properties to document the change after it has been applied. Option C. Initiate a formal change request, document the proposed modification, assess its potential impact on other virtual machines and the vSphere environment, and schedule testing in a non-production environment before implementing it in production. Option D. Inform the stakeholder that the request cannot be fulfilled due to the lack of prior testing and documentation, and advise them to wait for the standard change management cycle. The correct answer is C. Initiate a formal change request, document the proposed modification, assess its potential impact on other virtual machines and the vSphere environment, and schedule testing in a non-production environment before implementing it in production. Explanation: this scenario presents a professional challenge due to the inherent conflict between immediate operational needs and the long-term integrity of the virtualized environment. The stakeholders' request for a quick fix, while understandable from a business perspective, bypasses established change management and testing protocols. This creates a risk of introducing instability, security vulnerabilities, or performance degradation that could have significant downstream consequences. Careful judgment is required to balance the urgency of the request with the need to maintain a robust and compliant infrastructure. The correct approach represents best professional practice because it prioritizes adherence to established change management processes and thorough testing. This ensures that any modifications are documented, assessed for impact, and validated before deployment, minimizing the risk of unintended consequences. By following these procedures, the IT professional upholds their responsibility to maintain the security, stability, and performance of the data center virtualization environment, aligning with the principles of responsible IT management and operational excellence. This proactive stance prevents potential breaches, downtime, and data loss, which are critical considerations in any regulated environment. An incorrect approach that involves directly implementing the requested change without proper review and testing fails to uphold professional standards. This bypasses crucial validation steps, increasing the likelihood of introducing errors or security flaws. Such an action could lead to system instability, data corruption, or unauthorized access, all of which carry significant operational and potentially regulatory implications. Ethically, it represents a failure to act with due diligence and to protect the integrity of the systems entrusted to the IT professional. Another incorrect approach, such as outright refusal without offering alternatives or explaining the risks, demonstrates poor communication and stakeholder management. While technically adhering to process, it fails to address the underlying business need and can damage professional relationships. A more constructive approach would involve engaging with the stakeholder to understand the urgency and explore potential interim solutions that can be implemented within a controlled framework, or to clearly articulate the risks and timelines associated with a proper implementation. The professional reasoning process for similar situations should involve a structured approach. First, thoroughly understand the stakeholder's request and the underlying business need. Second, assess the request against existing policies, procedures, and best practices, including change management and security protocols. Third, identify potential risks and impacts of fulfilling the request, both immediate and long-term. Fourth, communicate these risks and potential solutions clearly and professionally to the stakeholder, offering alternatives where possible. Finally, document all decisions and actions taken, ensuring transparency and accountability. This systematic approach ensures that decisions are informed, justifiable, and aligned with professional responsibilities. Question 13. Implementation of a new virtual machine for a critical business application is urgently required by a development team. The standard change control process for VM deployment typically takes 48 hours to complete, but the development team needs the VM within 8 hours to meet a critical deadline. The infrastructure team has the technical capability to provision the VM rapidly, but doing so would bypass the standard security hardening and compliance checks. Which of the following approaches best represents professional best practice in this scenario? Option A. Refuse to provision the virtual machine until the standard 48-hour change control process is fully completed, advising the development team to adjust their project timeline. Option B. Provision the virtual machine with the necessary technical resources, but skip all security hardening and compliance checks to save time, assuming the development team will manage security on the VM. Option C. Immediately provision the virtual machine with default settings to meet the urgent deadline, and inform the development team that security and compliance checks will be performed at a later, unspecified time. Option D. Initiate a documented, expedited change request process that includes a risk assessment and temporary, compensating controls for security and compliance, with a commitment to complete full hardening and checks within 24 hours of initial deployment. The correct answer is D. Initiate a documented, expedited change request process that includes a risk assessment and temporary, compensating controls for security and compliance, with a commitment to complete full hardening and checks within 24 hours of initial deployment. Explanation: the scenario presents a common challenge in data center virtualization, balancing the need for rapid deployment of new virtual machines, VM, with the critical requirement of maintaining data integrity and compliance with established operational procedures. The challenge lies in the potential for shortcuts to introduce security vulnerabilities or violate data handling policies, which could have significant regulatory and business implications. The correct approach emphasizes a structured, documented, and authorized process for deploying new VMs, even under pressure. This aligns with best professional practices by ensuring that all deployments adhere to security baselines, configuration standards, and audit trails. This methodical approach minimizes the risk of misconfigurations, unauthorized access, and data breaches, thereby upholding the organization's commitment to data protection and regulatory compliance. It demonstrates a proactive stance on risk management and operational excellence. An incorrect approach that bypasses standard change control procedures for expediency is professionally unacceptable. This failure directly contravenes the principles of good governance and operational security. Such an action creates an unmanaged environment where security configurations might be overlooked, leading to potential vulnerabilities that could be exploited. This also undermines the auditability of the environment, making it difficult to track changes and identify the root cause of any future issues. Furthermore, it sets a dangerous precedent for future operations, encouraging a culture of noncompliance. Another incorrect approach, focusing solely on the technical functionality of the VM without considering its security posture or data handling implications, is also professionally unsound. This narrow focus ignores the broader responsibilities of a virtual infrastructure administrator, which include ensuring that all deployed resources meet security and compliance requirements from the outset. Failing to integrate security and compliance into the initial deployment phase leads to technical debt and increases the likelihood of future security incidents or regulatory violations. The professional reasoning framework for such situations involves a risk-based decision-making process. Before taking any action, a professional should assess the potential risks associated with each available option, considering technical, security, and compliance implications. This includes consulting relevant policies, standards, and change management procedures. If time constraints are a factor, the professional should explore options for expedited review or temporary documented deviations that still maintain a baseline level of security and auditability, rather than outright bypassing established processes. Prioritizing adherence to established protocols, even when inconvenient, is a hallmark of professional integrity and responsible IT management. Question 14. The efficiency study reveals that a critical application hosted on VMware vSphere 6.5 is experiencing intermittent performance degradation, specifically related to storage I/O. The virtualization administrator needs to address this issue. Which of the following actions best represents a professional and compliant approach to resolving the storage bottleneck? Option A. Disable advanced storage features like storage vMotion and vSAN, as they are known to consume resources, and observe if performance improves. Option B. Implement a storage tiering solution by migrating frequently accessed data blocks to higher performance storage arrays after a thorough analysis of I/O patterns and a successful test migration in a staging environment. Option C. Immediately reconfigure the storage array's RAID level to a more aggressive configuration to boost throughput, without validating the impact on data redundancy or application compatibility. Option D. Procure and install new, higher capacity storage drives across all arrays, assuming that increased capacity will automatically resolve the I/O bottleneck. The correct answer is B. Implement a storage tiering solution by migrating frequently accessed data blocks to higher performance storage arrays after a thorough analysis of I/O patterns and a successful test migration in a staging environment. Explanation: the efficiency study reveals a significant performance bottleneck in the virtual machine storage subsystem, impacting application responsiveness and user experience. This scenario is professionally challenging because it requires balancing the immediate need for performance improvement with the potential risks of disruptive changes to a production environment. Decisions must be made without compromising data integrity, security, or compliance with VMware's best practices, and the underlying regulatory framework governing data center operations. The chosen approach must demonstrate a thorough understanding of the impact of storage configuration changes on virtualized workloads. The correct approach represents best professional practice because it prioritizes a controlled, phased implementation of storage optimizations. This involves detailed planning, thorough testing in a non-production environment, and a rollback strategy. This aligns with professional ethics and regulatory expectations for change management, ensuring minimal disruption and risk to critical business operations. It demonstrates due diligence in assessing potential impacts before affecting live systems, a cornerstone of responsible IT management. An incorrect approach that involves immediately reconfiguring production storage arrays without prior testing is professionally unacceptable. This constitutes a significant regulatory failure by disregarding established change control procedures, which are often mandated by compliance frameworks to prevent unintended consequences and ensure auditability. It also represents an ethical lapse by exposing the production environment to unnecessary risk, potentially leading to data loss or extended downtime, which can have severe business and reputational repercussions. Another incorrect approach, such as disabling certain storage features to improve perceived performance without understanding their underlying purpose or dependencies, is also professionally unsound. This can lead to subtle but critical failures in data protection, replication, or disaster recovery mechanisms, violating implicit or explicit service level agreements and potentially contravening data governance regulations. It demonstrates a lack of comprehensive impact assessment and a superficial understanding of the storage architecture. A third incorrect approach, focusing solely on hardware upgrades without analyzing the virtual machine configuration or application behavior, fails to address the root cause of the bottleneck. This is a wasteful and inefficient use of resources, and while not directly a regulatory violation, it represents poor professional judgment and a failure to meet the fiduciary responsibility of optimizing IT infrastructure effectively. It neglects the holistic view required for effective data center virtualization management. The professional reasoning process for similar situations should involve a structured impact assessment framework. This includes identifying the problem, defining the scope of the investigation, evaluating potential solutions, assessing the risks and benefits of each solution, developing a detailed implementation plan with rollback procedures, and conducting post-implementation monitoring and validation. This systematic approach ensures that decisions are informed, risks are mitigated, and objectives are met in a compliant and ethical manner. Question 15. The monitoring system demonstrates a consistent, albeit minor, increase in latency for a specific set of virtual machines following a recent network configuration change. The increase is not yet impacting user experience significantly, but it is a deviation from baseline performance. Option A. Immediately revert the network configuration change without further investigation to restore baseline performance. Option B. Initiate a rollback of the network configuration change and conduct a detailed post-mortem analysis of the change process and its impact. Option C. Ignore the latency increase, assuming it is within acceptable operational variance and will self-correct. Option D. Implement a temporary workaround, such as increasing the allocated resources to the affected virtual machines while deferring a full investigation. The correct answer is B. Initiate a rollback of the network configuration change and conduct a detailed post-mortem analysis of the change process and its impact. Explanation. This scenario presents a professional challenge because it requires balancing the immediate need for system stability with the long-term implications of potential performance degradation and security vulnerabilities. The core of the challenge lies in accurately assessing the impact of a proposed change on a critical production environment without causing disruption. Careful judgment is required to avoid both overreaction and complacency. The correct approach represents best professional practice because it prioritizes a structured and data-driven impact assessment. This aligns with the principles of responsible IT management, which emphasize proactive risk mitigation and informed decision-making. By thoroughly analyzing the potential effects on performance, availability, and security, and by involving relevant stakeholders, the IT team can make a well-reasoned decision that minimizes the risk of negative consequences. This methodical approach ensures that changes are implemented only after their implications have been understood and addressed, thereby upholding the integrity and reliability of the virtualized data center. An incorrect approach that involves immediately reverting the change without further investigation fails to learn from the observed behavior. This can lead to recurring issues and a lack of understanding of the underlying cause, potentially masking a more significant problem. It represents a failure in systematic problem solving and a missed opportunity for improvement. Another incorrect approach, which is to ignore the alerts and assume they are false positives, is a significant regulatory and ethical failure. It demonstrates negligence and a disregard for system health and security. It directly contravenes the responsibility to maintain a secure and operational environment, potentially exposing the organization to data breaches, service disruptions, and non-compliance with data protection regulations. This approach prioritizes convenience over due diligence. A further incorrect approach, which is to implement a temporary fix without a root cause analysis, also represents a failure in professional practice. While it might address the immediate symptom, it leaves the underlying issue unresolved, increasing the likelihood of recurrence and potentially leading to more complex problems down the line. This is a reactive rather than a proactive stance, which is not conducive to maintaining a robust and resilient infrastructure. The professional reasoning framework for similar situations should involve a multi-step process. 1. Acknowledge and document the observed anomaly. 2. Initiate an immediate but contained investigation to gather more data. 3. Consult relevant documentation and historical data. 4. Engage with subject matter experts and stakeholders. 5. Formulate hypotheses about the cause and potential impact. 6. Design and execute controlled tests or simulations if feasible. 7. Based on the assessment, decide on the appropriate course of action, which could range from immediate remediation to further investigation or plan change. 8. Document the entire process and the final decision. Question 16. Benchmark analysis indicates that a critical VMware vSphere 6.5 upgrade is scheduled for the upcoming quarter. Without a formal impact assessment process in place, what is the most prudent course of action to ensure minimal disruption to business operations and data integrity? Option A. Conduct a comprehensive impact assessment involving all relevant stakeholders, identifying potential technical, operational, and business consequences, and developing detailed mitigation and contingency plans. Option B. Prioritize the upgrade based on vendor recommendations and immediate IT team availability, deferring detailed impact analysis until after the upgrade is completed. Option C. Proceed with the upgrade based on vendor documentation and informal discussions with a few key IT team members, assuming minimal impact due to the upgrade's nature. Option D. Implement the upgrade during a scheduled maintenance window, relying on rollback procedures if any issues arise, without prior detailed impact analysis. Correct answer is A. Conduct a comprehensive impact assessment involving all relevant stakeholders, identifying potential technical, operational, and business consequences, and developing detailed mitigation and contingency plans. Explanation. Scenario analysis. This scenario presents a common challenge in IT infrastructure management: the need to implement significant changes while minimizing disruption to critical business operations. The professional is tasked with a VMware vSphere upgrade, a process that inherently carries risks of downtime, performance degradation, and data loss. The challenge lies in balancing the technical necessity of the upgrade with the business imperative of continuous service availability. This requires a thorough understanding of the potential impacts, a robust plan to mitigate them, and clear communication with stakeholders. The absence of a formal impact assessment framework significantly elevates the risk of unforeseen consequences. Correct approach analysis. The correct approach involves a structured and comprehensive impact assessment. This process, aligned with best practices in IT service management and risk management, necessitates identifying all potential consequences of the vSphere upgrade across various domains: technical, e.g., application compatibility, performance, network latency; operational, e.g., downtime, support workload; and business, e.g., revenue loss, customer dissatisfaction. It requires engaging with application owners and business units to understand their dependencies and tolerance for disruption. The outcome is a detailed report outlining risks, mitigation strategies, and contingency plans, which forms the basis for informed decision-making and stakeholder buy-in. This systematic approach ensures that potential negative effects are proactively identified and managed, thereby safeguarding business continuity and minimizing operational risk. Incorrect approach is analysis. Proceeding with the upgrade without a formal impact assessment is a significant regulatory and ethical failure. It demonstrates a disregard for due diligence and a failure to adhere to principles of responsible IT governance. This approach risks causing unforeseen service disruptions, data corruption, or application failures, which can have severe financial and reputational consequences for the organization. It also violates the implicit ethical obligation to protect the organization's assets and ensure the reliability of its IT services. Implementing the upgrade based solely on vendor recommendations, without considering the specific environment's unique configurations and dependencies, is another failure. Vendor documentation provides general guidance, but cannot account for the intricate interdependencies within a specific data center. This oversight can lead to unexpected compatibility issues or performance bottlenecks that were not anticipated. Relying on informal discussions with a few key IT personnel to gauge potential impacts is insufficient. This approach lacks the rigor and breadth required for a comprehensive assessment. It risks overlooking critical dependencies or the concerns of less vocal but equally important stakeholders, leading to blind spots in the risk mitigation strategy. Professional reasoning. Professionals in this field must adopt a proactive and systematic approach to change management. This involves establishing and adhering to a formal impact assessment process for all significant infrastructure changes. The decision-making framework should prioritize risk identification, analysis, and mitigation. This includes 1. Defining the scope of the assessment. 2. Identifying all affected systems, applications, and business processes. 3. Quantifying potential impacts, e.g., downtime duration, performance degradation. 4. Developing mitigation strategies and contingency plans. 5. Communicating findings and plans to all relevant stakeholders. 6. Obtaining formal approval before proceeding with the change. This structured process ensures that decisions are informed, risks are managed, and business objectives are protected. Question 17. The investigation demonstrates that a proposed network configuration change within the VMware vSphere 6.5 environment has been identified as potentially impacting multiple virtual machines hosting critical business applications. Which of the following approaches best represents a professional and compliant method for assessing the impact of this change? Option A. Implementing the network change immediately to observe any immediate issues and addressing them reactively as they arise. Option B. Relying on historical data from previous unrelated network changes to infer the potential impact of the current modification. Option C. Conducting a series of informal discussions with the senior network administrator to gather their opinion on the potential effects and proceeding based on their verbal assurance. Option D. Developing a detailed impact assessment document that outlines all affected virtual machines, their dependencies, potential failure scenarios, and proposed mitigation strategies, followed by a formal review process. The correct answer is C. Conducting a series of informal discussions with the senior network administrator to gather their opinion on the potential effects and proceeding based on their verbal assurance. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent complexity of assessing the impact of a significant infrastructure change on a virtualized data center environment. The challenge lies in accurately predicting and quantifying potential disruptions to critical services, ensuring compliance with internal policies and potentially external service level agreements, SLAs, and making informed decisions that balance operational efficiency with risk mitigation. The need for a thorough impact assessment is paramount to avoid unforeseen downtime, performance degradation, or security vulnerabilities. Correct approach analysis. The correct approach involves a systematic and comprehensive evaluation of the proposed changes. This includes identifying all affected components within the virtualized environment, VM, storage, networking, security configurations, analyzing dependencies between these components and business applications, and assessing the potential consequences of failure or degradation. This methodology aligns with best practices in IT service management and risk management, ensuring that all potential risks are identified, analyzed, and addressed proactively. From a regulatory and ethical standpoint, this thoroughness demonstrates due diligence in protecting the integrity and availability of data center services, which is often a requirement for maintaining customer trust and adhering to industry standards for operational resilience. Incorrect approach is analysis, an approach that relies solely on anecdotal evidence or the experience of a single senior engineer, without formal documentation or broader team consultation, is professionally unacceptable. This failure stems from a lack of objective data and a reliance on potentially biased or incomplete personal knowledge, which can lead to overlooking critical dependencies or risks. Ethically, it fails to uphold the principle of collective responsibility for system stability and can expose the organization to significant operational and financial risks. Another incorrect approach would be to proceed with the changes without any form of pre-implementation testing or rollback plan. This demonstrates a disregard for established change management procedures and a failure to implement adequate safeguards. Such an approach is a direct violation of professional responsibility to ensure system stability and availability, potentially leading to severe service disruptions and reputational damage. It also fails to meet the implicit or explicit requirements of maintaining a resilient and reliable IT infrastructure. A third incorrect approach involves prioritizing speed of implementation over the completeness of the impact assessment. While efficiency is important, rushing through a critical assessment process without due diligence is professionally negligent. This can result in overlooked risks that manifest as critical failures post-implementation. Ethically, it prioritizes short-term gains over long-term system health and service continuity, which is a failure to act in the best interest of the organization and its stakeholders. Professional reasoning. Professionals should adopt a structured decision-making process that begins with clearly defining the scope and objectives of the impact assessment. This involves engaging relevant stakeholders, identifying all potential impacts, technical, operational, security, business, and utilizing established methodologies for risk analysis and mitigation planning. A critical step is to document all findings and recommendations, ensuring transparency and accountability. Before implementing any significant change, a formal review and approval process based on the comprehensive impact assessment should be in place. This framework ensures that decisions are data-driven, risk-aware, and aligned with organizational objectives and professional standards. Question 18. What factors determine the most appropriate strategy for applying a critical security patch to a VMware vSphere 6.5 environment that hosts a mix of production and development virtual machines, considering the potential for performance degradation and service interruption? Option A. Applying the patch to a single, isolated non-production virtual machine as the sole testing measure before proceeding with production deployment. Option B. A comprehensive risk assessment, including testing the patch in a non-production environment, validating its impact on critical applications, and scheduling deployment during a planned maintenance window. Option C. Immediate application of the patch to all production virtual machines to ensure the highest level of security across the entire infrastructure. Option D. Deferring the patch indefinitely until a completely risk-free deployment method can be identified, regardless of the security vulnerability. The correct answer is B. A comprehensive risk assessment, including testing the patch in a non-production environment, validating its impact on critical applications, and scheduling deployment during a planned maintenance window. Explanation. This scenario presents a common challenge in data center virtualization, ensuring the integrity and availability of critical systems while managing resource constraints and potential performance impacts. The professional challenge lies in balancing the immediate need for a security patch with the potential for disruption to production workloads. Careful judgment is required to assess the risk of applying the patch versus the risk of not applying it, considering the specific environment and its dependencies. The correct approach involves a thorough risk assessment and a phased deployment strategy. This represents best professional practice because it prioritizes minimizing disruption to business operations while still addressing the security vulnerability. By testing in a non-production environment, validating the patch's impact on key applications, and scheduling the deployment during a maintenance window, the administrator adheres to principles of responsible system management and operational continuity. This aligns with general IT best practices for change management and risk mitigation, which are implicitly expected in professional virtualization environments. An incorrect approach would be to immediately apply the patch to the production environment without prior testing. This represents a significant regulatory and ethical failure because it disregards the potential for catastrophic system failure, data loss, or extended downtime, which could have severe business and financial consequences. It demonstrates a lack of due diligence and a failure to uphold the professional responsibility to protect the integrity and availability of the systems entrusted to the administrator. Another incorrect approach would be to delay the patch indefinitely due to fear of any potential impact, even after acknowledging a security vulnerability. This also constitutes a regulatory and ethical failure. It exposes the organization to known security risks, potentially leading to breaches, data theft, or compliance violations, depending on the nature of the vulnerability and the data handled by the virtualized environment. Professionals have an ethical obligation to address known security threats in a timely and appropriate manner. A third incorrect approach would be to apply the patch to a single, non-critical virtual machine as a sole test. While better than no testing, this is insufficient. It fails to account for the interconnectedness of virtualized systems and the potential for cascading failures or performance degradation across the entire data center. This demonstrates a superficial understanding of the virtualization environment and a failure to conduct a comprehensive risk assessment. The professional decision-making process for similar situations should involve a structured approach. 1. Identify the vulnerability and its potential impact. 2. Assess the criticality of the affected systems and their dependencies. 3. Develop a testing and deployment plan that includes a rollback strategy. 4. Communicate the plan and potential risks to stakeholders. 5. Execute the plan, monitoring closely for any adverse effects. 6. Document the entire process. Question 19. When evaluating the security posture of a VMware vSphere 6.5 environment that stores sensitive customer financial data, which of the following strategies best balances data protection requirements with operational efficiency, considering potential regulatory implications? Option A. Utilizing vSphere's native encryption capabilities only for specific virtual machines identified as high risk, while leaving other virtual machines unencrypted to reduce management overhead. Option B. Disabling encryption features on virtual machine disks and network traffic to maximize I/O performance, relying solely on perimeter security measures. Option C. Implementing data loss prevention (DLP) solutions that scan all data for sensitive information and flag it for review without encrypting the data itself. Option D. Implementing full disk encryption for all virtual machine disks and encrypting data in transit between SC hosts and the storage array, coupled with role-based access controls and regular security audits. The correct answer is D. Implementing full disk encryption for all virtual machine disks and encrypting data in transit between SC hosts and the storage array, coupled with role-based access controls and regular security audits. Explanation. This scenario presents a professional challenge related to data security and compliance within a virtualized data center environment. The core difficulty lies in balancing the need for efficient data access and system performance with the stringent requirements for data protection and privacy, particularly when dealing with sensitive customer information. A failure to implement appropriate security measures can lead to data breaches, regulatory penalties, and reputational damage. The correct approach represents best professional practice because it prioritizes a layered security strategy that aligns with established data protection principles. By implementing encryption at rest and in transit, along with robust access controls and regular security audits, the organization demonstrates a commitment to safeguarding sensitive data. This proactive stance is crucial for meeting compliance obligations and maintaining customer trust. An incorrect approach that involves disabling encryption to improve performance would be a significant regulatory and ethical failure. This action directly contravenes data protection regulations that mandate the protection of sensitive information. It exposes the organization to the risk of unauthorized access and data breaches, leading to severe legal repercussions, fines, and loss of business. Another incorrect approach, such as relying solely on network-level firewalls without considering data-level protection, is insufficient. While firewalls are a necessary component of security, they do not protect data once it has been accessed within the virtualized environment or if internal threats exist. This oversight creates vulnerabilities that can be exploited, leading to non-compliance and potential data compromise. Professionals should adopt a decision-making framework that begins with a thorough understanding of applicable data protection regulations and organizational policies. This involves conducting a risk assessment to identify potential threats and vulnerabilities. Security measures should then be selected and implemented based on their effectiveness in mitigating these risks, with a clear understanding of the trade-offs between security and performance. Regular review and updates to security protocols are essential to adapt to evolving threats and regulatory landscapes. Prioritizing compliance and data integrity over short-term performance gains is a hallmark of responsible IT management. Question 20. The performance metrics show a consistent increase in application response times for critical business application hosted on a VMware vSphere 6.5 environment. While overall host CPU and memory utilization appear within acceptable limits, individual virtual machines hosting the application exhibit elevated disk latency and occasional I/O wait times exceeding thresholds defined in the service level agreement. What is the most appropriate next step to diagnose and resolve this performance issue? Option A. Focus troubleshooting efforts on the network infrastructure connecting the application servers to the database servers, as latency is a symptom. Option B. Investigate storage performance at the data store and individual VM disk level, correlating with application I/O patterns. Option C. Immediately increase the allocated CPU and memory resources for the affected virtual machines to alleviate potential contention. Option D. Restart the affected virtual machines and the underlying EXE hosts to clear any transient issues. The correct answer is B. Investigate storage performance at the data store and individual VM disk level, correlating with application I/O patterns. Explanation. This scenario presents a common challenge in data center virtualization, identifying and addressing performance bottlenecks that impact application responsiveness and user experience. A professional challenge lies in accurately diagnosing the root cause of the observed performance degradation without resorting to guesswork or making changes that could introduce new issues or violate operational best practices. A systematic, data-driven approach is crucial to ensure efficient resource utilization and maintain service-level agreements, SLAs. The correct approach involves a methodical investigation of the virtual infrastructure, starting with the most likely culprits for performance issues. Analyzing CPU, memory, disk I/O, and network utilization at both the virtual machine, VM, and host levels provides a comprehensive view. Correlating these metrics with application-specific performance indicators allows for precise identification of the bottleneck. For instance, if application latency increases concurrently with high disk I/O wait times on a specific VM and its host, it strongly suggests a storage-related issue. This data-driven methodology aligns with professional best practices for performance troubleshooting, emphasizing evidence-based decision-making and minimizing disruptive changes. It also implicitly supports adherence to operational guidelines that mandate efficient resource management and service availability. An incorrect approach would be to immediately assume a specific component is at fault without sufficient evidence. For example, randomly increasing VM CPU or memory resources without confirming they are the actual limiting factors is inefficient and can lead to over-provisioning, wasting resources, and potentially masking other underlying problems. This reactive, unverified approach lacks professional rigor and could violate operational policies requiring justification for resource allocation changes. Another incorrect approach is to focus solely on network troubleshooting when the metrics clearly point to storage or compute as the primary bottleneck. This misdirection of effort delays resolution and can lead to unnecessary network configuration changes, potentially impacting other services. Such an approach demonstrates a failure to conduct a thorough and systematic analysis, which is a cornerstone of professional IT operations. Professionals should employ a structured troubleshooting framework. This typically involves 1. Defining the problem clearly based on observed symptoms and user impact. 2. Gathering relevant data from monitoring tools, logs, and application performance metrics. 3. Analyzing the data to form hypotheses about the root cause. 4. Testing hypotheses through targeted investigations or controlled changes. 5. Implementing a solution and verifying its effectiveness. 6. Documenting the findings and resolution. This systematic process ensures that decisions are based on facts, minimizing risk and maximizing the likelihood of a successful and sustainable resolution.